Okay everyone, welcome back. This is Mr. Morrissey. Today we're looking at quadratic inequalities. Basically we're just going to be graphing quadratics and looking for solutions to inequalities. We will either do it algebraically or graphically. Remember, you can always pause the lessons if it's going too fast or you want to sit back and reflect on what we're doing. But let's start it right away. Solve x squared minus 11x is greater than or equal to negative 28. Well, an equivalent, I'll write it again. An equivalent form would be to add 28 to both sides. So we're going to factor. Now we're starting off with a relatively straightforward problem, so you can probably assume that it's going to be able to be factored easily. 28, 7, and 4. Negative 4 times negative 7 is positive 28, and negative 4 plus negative 7 is negative 11. So we do a rough, quick little sketch here. 4, 7. Since this is a positive 1x squared, you know the graph is facing up. And we know the y-intercept is 28. It doesn't really matter in terms of this problem. We're not even finding the vertex. We look on the graph and we see that we're going to be greater than or equal to 0 at 7 and all these points, and at 4 and all those points. So done. The answer is x is less than or equal to 4 or greater than or equal to 7. If you wanted to do a test point, you could say plug in 5. Okay? If I say 5, if I plug in 5, is that greater than or equal to 0? Well, 5 minus 4 is positive. 5 minus 7 is negative. A positive times a negative is negative. Is a negative greater than or equal to 0? No. So you know you've done it right. You could test any point to the right of 7, any point to the left of 4. You'll get true statements. Next question. Solve x squared minus 7x plus 4 is greater than, this time, 5x minus 2. Okay, this one's not going to factor properly. So let's see. X squared, subtract the 5 over, and add 2 to both sides. This does not factor. Okay, so we need to throw this into the quadratic formula. So let's do that right now. Oops. Yeah. So 144 minus 24 is 120. Now 120 does simplify, so let's do that up here. Two times 2 times 2 times 3 times 5. So these 2's can be simplified. If you think of it like this, guys. These two 2's can come on the outside. And what you're left with is 6 times 5, or 30. So So 6 plus or minus root 30. Root 30 cannot be simplified. So we just do a little graph. Now this is a little bit tricky. Okay. So 6 plus root 30 we know is positive. So I'm going to put a little dot right here. 6 plus root 30. Now what I want to know is 6 minus root 30. Is that positive or negative? Like, should I put the dot over here and draw a parabola? Should I put the dot in the positive area and draw a parabola? So without a calculator, it's a good skill to know how to estimate this. So 6 that's the same thing as the square root of 36. And what am I doing? I'm doing minus the square root of 30. The square root of 36 is bigger than the square root of 30. So this is going to be a positive number. So somewhere in the positive area, we're going to have this. Okay? So there's my quadratic. Now I want to look back. I want to know where all the points are that are greater than 0. Well, they're greater than 0 here and here, but they do not include 6 plus root 30 or 6 minus root 30. So the answer to this problem is this. There is my answer. Okay? All right, we'll go to number 3, then we'll take a break. Okay, graph the system of inequalities. Okay. This is going to take me a couple minutes to do. So let's take a look first at the first one. So y is less than or equal to negative x squared plus 4x minus 4. I'm going to factor out a negative here. X squared minus 4x plus 4. We're going to see real quick that this becomes x minus 2 times x minus 2 squared. Okay, so this is, if we do a graph, this is a parabola that's upside down because of this negative, and at 2 we get a point. Okay, so there's that. We get upside down. We know that the y-intercept is negative 4, and we know this point here is 2. It's a rough sketch, but the vertex here is 2, 0. All right, so there's part 1. Now, it says we want points less than or equal to those points. So we need to do a test point. And read in the notes, it talks about the test point. So the test point. I'm going to choose 0, 0. So is 0 less than or equal to 0 plus 0 minus 4? That's not true, so that's false. So we're going to shade not in the 0, 0 area, but we're going to shade down here, inside the parabola. So if the question had just been this, the answer would have been this, with the shading inside the parabola. This is greater than or less than or equal to, so it's a solid line. Done. Now, the second equation, y is less than 2x squared plus x minus 8. This one's hard because this doesn't factor. So we're going to need to use the quadratic formula. Okay? So let's see. Quadratic formula. So take a sip of water here. This is 8 times 8, 64. So this is 1 minus Okay. So, here are the key things here. Here are the two roots. Now, 65 is very close to 64. Okay? So, when we do negative 1 minus root 65, that's really almost like, it's a little bit, it's negative 1 minus, it's like this, negative 1 minus 8 over 4, but it's a little bit more than 8. So it actually, if you were to put, where's my other, 1, 2. So negative 1 minus root 65 is a little bit more than saying negative 1 minus 8, because the square root of 64 is 8. So this we're thinking maybe this is negative 9 over 8, which is 2 something. If you were to say negative 9 over 4, that's going to be 2.5. Or no, 2.25. So what I'm trying to say is, since this is root 65, you're subtracting a little bit more. So it's going to be even more over past negative 2. So here's the first point. The second point is a little bit less than 2. Okay, you could verify that on the calculator, or you could figure it out, you could estimate it using square roots. And the graph is going to look something like this. I have a dotted line because it's less than, so that's dotted. And now we do a test point. Let's test 0, 0. So is 0 less than 0 plus 0 minus 8? You can see clearly that that's false. So you are not going to shade the 0, 0 area. You're going to shade everything on the outside. But since you want the intersection, the answer is going to be all of the area in here. Technically, guys, it doesn't include this dotted line, but that would be really hard to express. But the answer is the overlapping space, and there it is. This was a hard problem. Couple days in a row, the example 3 have always been the hardest. I'm not doing that on purpose. Okay. The key thing here, this is solid line. This is dotted. And here we factored out a negative to get into vertex form. Here we had to use the quadratic formula. And that's about it. All right, guys. We'll take a break now. Bye.